which is three-dimensional figures. Okay, so when we're looking at these, we can have vertices, which are the points where they come together. Faces are the sides, and edges are the lines. So when you're doing this, you just have to tell me what it is, and it's named by its base, and then how many of them that there are. Okay? So let's run through this. Prism has two bases, two parallel bases. They're named by their bases. This would be a triangular prism. Cylinder is a special name for a circular prism. Pyramid has one base, and it's named for that base, so this would be a triangular pyramid. Cone is a special name for a circular pyramid. Okay? So let's give it a whirl. So there's a whole bunch of different shapes. You can see a prism named by its base. Pyramid also named by its base, but it comes to a point. Okay? So prisms have two bases. Pyramids have one base, and go from there. All right, so what we're going to do when I ask you to do these is classify the figure. Well, I look at this and I can see it is a prism. It is a square/rectangular prism, kind of hard to tell. Vertices. How many vertices do we have? Well, count them. 1, 2, 3, 4, 5, 8 vertices. Edges are the lines, so 4, 4, and 4 would be 12. And bases. Bases are only the bases. So a prism always has two bases. Now, faces would be 6. 1, 2, there's 4, and then the two bases, so 6 total faces. So remember, bases are faces, but faces are not necessarily bases. Hope that makes sense. All right, let's try that again. Classify the figure. Well, I can see that I've got a pyramid here. 1, 2, 3, 4, 5-sided, so that would be a pentagonal pyramid. How many vertices? 1, 2, 3, 4, 5, 6 vertices. Edges, there's 10, because there's 5 on the bottom and 5 up the sides. And bases, well, it's a pyramid, so it only has one base. It does have 6 faces, but only one base. So make sure we understand the difference. All right, a net is a diagram where you can basically unfold a three-dimensional shape and make it a net, make it two-dimensional. So basically what we just have to name is what three-dimensional shape is this if I fold it up? What do you guys think? If I fold all that up, I think I'm looking at a cube or some sort of square prism or even a rectangular prism. All of those answers would be correct. What about this half-person thing here? Well, if I roll that up, that actually is a cone. It's a cone. Okay? What about this? Fold that up. Triangular pyramid. Triangular pyramid. And then last but not least, the cross-section. The cross-section is the intersection of a three-dimensional figure in a plane. So a cross-section is like, hi-ya! What do I get when I cut it? Okay? So if I cut the top of that cone, what's left on the sheet of paper there? That would be a vertex. Okay? What about here? If I cross-section in the middle of that cone, 1, 2, 3, 4, 5, I'm looking at a pentagon. A pentagon. Okay? What about that cross-section? 1, 2, 3, 4, 5, 6. I'm looking at a hexagon. So the cross-section is the two-dimensional object. What about the cross-section of this cone? Well, that makes a triangle. Triangle. Okay? All right. A piece of cheese is a prism with equilateral triangular bases. How can you cut the cheese to make each shape? All right. So I've got my equilateral triangle here. I'm having a party. I want cheese that is in triangles. How am I going to cut that? I want to cut it like this, right? So the words we're going to be looking for on this, and I believe there is a question like this on your assessment, is parallel to the base. Okay? If I want equilateral triangles, there's my base. I'm going to make parallel to the base. Okay? And they actually drew it for us. So there you go. Parallel to the base. Same block of cheese, but this time I want to make rectangles. Well, then I'm going to want to cut it the other way, which would be perpendicular to the basis. So when you're looking at these types of problems, you got to make sure that you're cutting it parallel to the base, perpendicular to the base, depending on what it's asking you. But those are the types of things that I'm looking for. Okay? All right.